Okay, we come to problem number, I'm not even sure which problem this is. I want to say 23. I might be maybe a 22 or 23. I guess I'll look and make sure. Yes, 22. All right. Which statement about the quadratic parent function, of course, that's y equals x squared, or f1 of x or f2 of x equals x squared, is true? Its graph is symmetrical about the x-axis. Let's see, let's look at the x-axis, of course. There's the x-axis. Is it symmetrical about this axis? Absolutely not. It will be reflected. So we can kind of throw that one. We can definitely throw that one away. All right. Is it symmetrical about the y-axis? Well, yep. It's a mirror image. As a matter of fact, you can see that that looks like a perfect mirror. So looking pretty good for G there. Okay. Its domain is the set, even though we know the answer is G. Let's look at this. Its domain is a set of all non-negative numbers. What are all the non-negative numbers? Matter of fact, I can get rid of this line there. Its domain. So if we're talking about domain, then we know we're talking about the x-axis. So I'm going to put, let's put a blue line. So if we're talking about all the non-negative numbers, non-negative, then the first non-negative number is 0, and then it just goes on and goes on, goes on. That would be the domain of, that will be the set of all non-negative numbers. In other words, but if you look at the graph, this graph extends infinitely in both directions. So this continues on forever, and this continues on forever. So actually the domain of this graph is more this. It actually goes from, it continues on. So actually the domain of this graph is all of the real numbers, not just the non-negatives. So the domain is all reals because it's the entirety of the x-axis as this function continues infinitely in both directions. You know, because you're almost like I need a little arrow there. I can't really make an arrow there. I have to do better than that. Okay, so we know definitely H is not true. What about his range? Then is range, if his range was the set of real numbers, all of them. Let's see if I can get rid of this. That's his domain. Let's look at the range of the parent quadratic function. As you can see, the function doesn't even exist in the negatives. If we just look at the y-axis, it actually picks up right at 0, and then it goes up from there forever. So its range is actually all y bigger than 0. So all real numbers bigger than 0. So the only statement that is true is that its graph is symmetrical about the y-axis, and that you can tell just from what I drew here.